Let us solve question number 4, guys. So what we have here, craft temperature is the temperature, okay, below which aqueous solution of detergents starts freezing, above which formation of mishal takes place, below which formation of mishal takes place, above which aqueous solution of detergent starts boiling. Okay, so what is the definition of craft temperature, guys? The definition says it is the temperature above which mishal formation takes place. That's why the answer is option 2, guys. Very simple question, I will say, just on the basis of definition. Let us go on to next question. Okay, arrange the following solutions in decreasing order of pOH. Okay, so we have to find the pOH of these solutions which are given. So the first one is 0.01 molar HCl, second one is 0.01 molar NaOH, third one is 0.01 molar CH3COONA and 0.01 molar NaCl. Okay, so what would be the pH of 0.01 molar HCl? Let's see. The pH would be, the pH is 2 because the concentration is 10 to the power minus 2. So pH is 2, so pOH will be how much? pOH will be 12. Okay, second solution is a basic solution, so pOH will be how much? So this is 10 to the power minus 2 molar, so pOH will be how much? 2. Third solution, it is a salt of weak acid strong base. It is a salt of what? Weak acid strong base. So the pH would be what? pH would be greater than 7. If pH is greater than 7, then pOH would be less than 7, right? So pOH will be less than 7, but it will be higher than what? It will be higher than the second solution. It will be higher than the second solution. Fourth solution, 0.01 molar NaCl. It is a salt of strong acid and a strong base, guys. Okay, so a salt of strong acid strong base, pH is how much? pH is 7. So pOH is also 7. Okay, so we have the pOH of all the 4 solutions, so we can easily arrange them. Yes, so the one which has the lowest pOH is the second solution, right? And the one which has the highest pOH is the first solution. So do we have any options like that? So we have second option where B has the least pOH, okay, and A has the maximum pOH. So the answer is option 2, guys. Okay, I hope you have understood this. You just had to find the pOH and solve this question, guys. Not a very difficult question. Let us move on to the next question. Okay, for the reaction Fe2N solid, 3/2 H2 gas, 2 Fe solid, ammonia gas, Kc is Kp into RT raised to half, Kc is equal to Kp into RT, Kc is equal to Kp RT raised to 3/2, Kc is equal to Kp RT raised to minus half. Okay, so here we have to find the relation between Kc and Kp. So how we'll go about this? Let's see. We will consider first of all only gases when we are talking about what? When we are talking about del N, because del N is applicable only for gases, right? So this will be what? 1 minus 3/2. So what we'll get over here, this will be minus half, right? So what is our equation? Equation is Kp is equal to Kc RT raised to del N. So what is your del N? Del N is minus half. So Kp is equal to Kc divided by RT divided by RT raised to half, right? Okay, so Kc is equal to, it will be equal to what? Kp into RT raised to half, right? So is this matching with the options which are given to us? Let's see. So the answer is option 1, guys. Yes, is this clear? Is the working clear? Yes, All of you understood? Yes. A simple sum, just that you should remember the relation between Kp and Kc. And second thing is, you just have to remember that del n, we have to take only gases. We don't consider solids for del n. Okay. Let us go on to the next question. Okay. The species that has a spin only magnetic moment of 5.9 bm is, okay. So TD stands for tetrahedral. First option MnBr4 2 minus, NiCl4 2 minus, NiCO4. Okay, so first three options are what? They are tetrahedral. And the last option that we have is NiCN4 2 minus is square planar. So let us look at the first option, guys. So Mn oxidation number is +2. Okay, you're talking about tetrahedral geometry. So how will be the splitting in tetrahedral geometry? We will have 3 orbitals of high energy and we will have 2 orbitals of low energy. What will be the configuration in M+2? Configuration will be a d5 configuration. Yes. So distribute the electrons 1, 2, 3, 4 and 5. Let us calculate the magnetic moment for this. Let us calculate the magnetic moment. What would be the magnetic moment? So magnetic moment is equal to square root of phi plus 2. So if I solve this, I get a value of how much? I get a value of 5.91 bm. Is that the value that we are looking for, guys? Yes, let's check. Yes, that is the value that we are looking for. So the answer is option 1, guys. So no need to solve the other options because we are getting the answer in the first option itself. Let us solve the next question.